Antimatter is a lot like matter, but the opposite. For every subatomic particle that makes up matter, there's a matching particle, an antiparticle, with the opposite electrical charge. But here's the problem. Scientists knew the antimatter had to be out there, but for the most part, they couldn't see it. Which is what brings us to one particular kind of antimatter, the antiproton. Again, Stu Loken.
The antiproton was the thing that would confirm that there was, in fact, an antimatter world in addition to the matter world that we see every day.
In other words, if scientists could produce an antiproton, it would mean that our understanding of the Big Bang and the makeup of our universe was basically on the right track. If not, well, it was back to square one. So they built the Bevatron to test that theory. Try and picture this. The experiment began with a thin cloud of hydrogen gas. First, scientists extracted protons from the hydrogen atoms and injected them into the accelerator chamber. As the protons whipped around and around the chamber, they went faster and faster until they approached the speed of light.
You want to get to a high enough energy that when the particles smash together, you can turn that energy into the production of new particles.
Which is exactly what happened. As the particles approached light speed, the Bevatron performed a feat Einstein himself had described with the equation E equals mc squared.
That mass and energy are different manifestations of the same thing.
Since mass and energy are essentially interchangeable, the Bevatron was able to transform matter into energy and energy back into matter. And in 1955, for the first time ever, antimatter.
We smashed proton against proton, and then in the end we had proton, proton, antiproton, and another proton to balance.
This work won Bevatron scientists the 1959 Nobel Prize in Physics. It was the first of 4 Nobels to come from research done here, as well as new insights into things like radiation treatment for cancer and how to keep astronauts safe from radiation in space. But by the late 1980s, the Bevatron had become obsolete. In 1993, it closed its doors for good. It is, says Stu Loken,
The end of an era.